okay? So on your sheet of paper, however you're doing it, I want you to write the date, and I've left a little gap for you to write whatever your date might be. The title, which is ionic bonding, and the keywords, okay? Because they're words that we're going to be using. It's really important to practice your scientific literacy. What I then want you to do is to pause the screen and have a go at answering the 6 questions, okay? They're not really hard. They're stuff that we've done before. You should be able to answer them, okay? If you can't, then you need to go back and have a think, Google, or just wait for me to answer them. Right, so question number 1 says to draw and label an atom, okay? You will get so bored of doing this question, but it's so important to keep thinking about what is inside an atom, which bits are where, okay? So here's just a quick one I've drawn. The electrons, okay, are on the outer, well, on the shells, okay, and they have a negative value, okay? They have a negative value. You've got the neutrons, okay, so neutrons have no charge. And then you have got your positive protons. Okay. Next question then says, name this number. So this number is the mass number. Name this number. That is the atomic number, okay? Remember, the mass number is the massive number, okay? Mass number means massive. Number 4, what is this called? Well, this is an element. I understand if some of you had written oxygen, because that's what it stands for, but I just want you to think, because that's what you'll get on your periodic table. That's what you get on your periodic table, so I just wanted you to think about all the different parts, okay? What can we use the mass number to work out? Okay, well, the mass number tells us the number of protons and neutrons added together. Okay, so I've just wrote P and N. What can you use the atomic number to work out? Well, you can use that to work out the number of protons, which is always equal to the number of electrons. Okay, so what we're going to do now is we're going to have quite a quick recap, hopefully it'll be quick, on the electronic structure of certain elements. So I'm going to go back to electronic structure. You should have done it year 9, but we're going to have a quick go. Okay, it's also in year 10. And then we're going to move on to a little bit of a tougher topic, which is ionic bonding. So just a quick recap, we've just done this today. Okay, so the mass number is the number of protons and neutrons. The atomic number is the number of protons or electrons. Remember, to work out neutrons, you just take them away from each other. But what is important to us today is the atomic number, which is a smaller number, which gives us the number of electrons, because we're going to focus on electron structure and then ionic bonding. So electron structure, all electrons orbit in the shells around the nucleus, but they have a special arrangement, okay? So not all electrons, say you've got 10 electrons because you've worked that out from the atomic number, they can't all go in the first shell, okay? There's a really important way of how they go in the shells, and you need to know it. Normally, we only work with the first 20 anyway, so it's 2, 8, 8, 2. You only have to be able to do the first 20, okay? You don't have to be able to do any more, okay? And don't worry, some of them don't quite fit if you go lower down. That's because they aren't in the first 20. So we only ever focus on the first 20, being able to put them in their shells, okay? The big thing to remember is that only 2 go in the first shell, okay? So I'm going to have a go at 2, and then you're going to have a go at a couple, okay? So we're going to do oxygen first. First thing you have to do is find the atomic number, okay? Remember, the atomic number is the smaller of the 2 numbers, okay, which tells you the number of electrons. So I know that I have got 8 electrons, okay? Then I want you to draw a nucleus, okay? We're just going to draw a nucleus as though it's a black dot. Sometimes you see it with the letter of the element, but oxygen's a bit hard because it looks like an O. So we're always going to draw the nucleus as though it's a black dot, okay? And then we're going to add our first shell, okay? Draw the electrons in the first shell, okay? So only 2 electrons can go in the first shell. So I'm going to draw them as crosses, and I'm going to think about my placing of them, okay? I'm not going to group them together. I'm not going to do that, okay? I'm going to spread them out. Normally, as though you're at 12 and at 6:30, or 12 and 6 on a clock, okay? Nice and spread out. Okay? Move to the next shell. Now, first what I need to do before I move to the next shell is I need to think about how many electrons I've got left. okay? So I started with 8, I do 8, take away 2, I've got 6 electrons left, okay? So 6 electrons left now to go in my next shell, okay? What I'm going to do is I'm not going to pair them up until they need to be paired up, okay? So I've got 6 electrons left, I'm going to go 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. I've only got 4 now. 8 can fit in this shell, so I'm then going to pair them up. So I'm going to do 2 there and 2 there. You've still got 2 that are unpaired, but that's fine because you've got 6 electrons in your next shell, okay? So make sure you're focusing on that. Sometimes you'll have to draw another shell, but don't worry about that because the oxygen doesn't need that. Count the number of shells. So the number of shells, you've got 1 shell, 2 shells. So that means it's in period 2. If I was looking on the periodic table, it would be in period 2. Count the number of electrons in the outer shell. So I've got 6 electrons in my outer shell. That means it would be in group 6, okay? So that allows me to find it on the periodic table. So I go period 2, go 1, 2, down, and then I go across to find group 6, okay? The numbers for group 6 would be at the top. So that's the first one. I'm going to have a go at another one. Might be useful for you to follow through and have a go at this one, okay? And then I'm going to leave you to have a go at quite a few. So, first thing we need to do is find the atomic number. The atomic number is the smaller number. So this time, I've got 12, okay? Draw the nucleus. Remember we spoke about how we're going to do our nucleus as a dark circle. And then I'm going to draw my first shell, okay? How many can fit in my first shell? 2. Remember I said nice and spread out, so we do them at 12 and 6, okay? Next thing I then need to do is do 12, take away 2. I've got 10 left, okay? How many can go in my next shell? Only 8 can go in my next shell. So I draw another shell and I fit the 8 in. Remember, we're thinking about a clock. Do not pair them up until they need to be. So 12, 3, 6, 9. That's only 4. We know 8 can fit in this shell, so go around again. I've now put 8 out of my 10 in that shell. So 10, take away 8. I've got 2 left. So I draw another shell and I put 2 in. Okay, you don't have to do them. You could, that's just thinking about spacing them out. I think, okay, it's gone like that. So we're going around our circle. Okay, so make sure you're counting, remembering how many can fit in each shell. Count the number of shells. So I've got 1 shell, 2 shells, 3 shells, okay? So my period is going to be period 3. Group, how many have I got in my outer shell? So I've got 1, 2 in my outer shell, so I'm going to write 2. So it's in period 3, group 2. What I'd like you to have a go at now, and you don't need a periodic table because I have given you the atomic numbers, so the smaller numbers, okay? Given you the smaller numbers, I'd like you to have a go. It might be quite useful to maybe pause on this screen. So go back and pause on that screen. Thinking about how you draw the electronic structures for these. Okay? Right, so you should have now had a go at them. I'm going to put up the next screen, so it might be useful for you to maybe pause to check your answers. So, ooh, they're moving around. So, neon. Neon is in group 0. Okay, you might remember from the last year. You can see why you think it would be in group 8. Okay, it's the noble gases, the ones on the end. They've got full outer shells. They're really stable. Okay, neon is in period 2, and you can see that I've drawn them. Make sure you're doing the crosses like that, so you can kind of count them to make sure you're doing it right. Chlorine then is in group 7 because it's got 7 in its outer shell. Period 3. Hydrogen, bit of a funny one. It's in period 1. You wouldn't really say it's in group 1. Okay, it's kind of on its own. It's like in the middle of the periodic table. Little bit of a strange element. Okay, I can understand why you think it was in group 1, and you write group 1 if it was asked of you, but it's not really in group 1. It doesn't have the same properties as though it was in group 1. Sodium then is definitely in group 1. It's got 1 in its outer shell. It's in period 3 because it's got 3 shells. Ooh, there we go. And then potassium. Then my circle's gone a little bit funny at the bottom there. Potassium then would be in group 1 again, but it's in period 4 because it's got 4 shells. Okay, they're not perfect drawings, okay, because I'm obviously just drawing with my pen like you would be. Don't worry about getting the circles exactly perfect, but hopefully we're all alright. There we go. All alright with that, okay? So again, if you need to pause the screen just to check your answers, that's great. So what you need to remember now to move on, so we've done electronic structure. What you need to remember now to move on is that atoms like to have full electron shells. They want to be like neon. They want to be like neon. They want to have a full outer shell. Okay? So, they want to have a full outer shell. So what is ionic bonding? Ionic bonding is when a reaction occurs between a metal and a non-metal.